Well, hello. Hopefully this little video will help you for those of you having trouble balancing the combustion reactions, which I think what makes these a little different than most of the equations that you've had to balance is that the oxygen on the product side appears not just in one of the products, but in each of the products, the water and the carbon dioxide. And that just makes counting them a little bit more challenging. You just have to be careful. So I'm going to do an ERP chart. I'm also going to use a pencil for this, just because I told you you're going to end up changing these coefficients, and so having something you can erase is certainly helpful. So I'll make my ERP chart here. And this is just, all this is a way of helping you to count, keep track of how many atoms of each element you've represented so far. So we've got some carbon, we've got some hydrogen, and we've got some oxygen represented in this particular reaction. So let me zoom in here, and that might help you see a little bit better. There we go. So on the reactant side, as it's written here, we have carbon only in this first compound, so there's 7 atoms of that. We have 12 atoms of hydrogen, and we have 2 atoms of oxygen. And on the product side, we've represented just 1 carbon, 2 hydrogens, but the oxygen, notice, shows up 2 different places. So this water molecule has 1, and the carbon dioxide molecule has 2. That's a total right now of 3 atoms of oxygen. So let's look and see where we need to add some coefficients to increase this. Now I'm changing to my pencil. So obviously with 7 carbons on this side, but only 1 over here, we're going to need more carbons. So how do we make 7 carbons show up on the product side? Well, if we just put a coefficient of 7 in here, that means I've got 7 of all these molecules, each one having a carbon and 2 oxygens. So now I change my product side to show 7 carbons, and I've also changed my oxygen. But be careful here. You don't just multiply it by 7 the way you did here. We have to remember that we have an oxygen molecule, an oxygen atom in the water molecule. So we have right now, we still have 1 here, plus we have 14 now represented over here. That's a total of 15 oxygen atoms represented. Okay, let's do the hydrogen next. I always recommend you wait till the end to do the oxygen, because you can always mess with this last oxygen on the reactant side to keep things balanced. So right now we've got 12 hydrogens here, but only 2 over here. So I need 6 times as many on the product side as what I have represented here. So if I change that to a 6, that means I now have the 12 hydrogen atoms I was looking for, but I've also changed my oxygen. So let's add up the total. I have 6 now represented here from these 6 water molecules. I still have 14 over here. That's a total of 20. See how my ERP chart just changed again? I had 3, then I had 15, now I have 20. So I'm in good shape on the carbon and the hydrogen. I just need to now get a whole lot more oxygen on the reactant side to account for the 20 that I've shown over here on the product side. Okay, now I don't have any oxygen in my first compound. So any change in oxygen will only happen here with this oxygen molecule. This is one of those we call a diatomic molecule. So I need 10 times as much oxygen over here as what I'm representing now. So a single coefficient of 10 will change this from 2 up to 20. And now my reactant and product side shows identical numbers for everything. You can do a double check up here, but everything is good now. So I have no coefficient here. That just means I have 1 of those molecules. But I have 10, 6, and 7 for my others. So this is balanced. My ERP chart shows it. Everything's good. So hopefully that might help you to do the ones that you have that might look a little different, but probably pretty similar to what the process is here that I've shown. Thanks for watching.